In this presentation, we will go over several examples involving the sampling distribution of sample means and sample proportions. Example 1 is a problem on American television viewing habits. According to Money magazine in 2003, the mean television viewing time for Americans is 15 hours per week. Suppose a sample of 64 Americans is taken to further investigate viewing habits. Assume the population standard deviation for weekly viewing time is 4 hours. Before we start working on any of the problems, it is essential to understand what the numbers appeared in this story problem mean. Let's start with the first one. 15 is the average television viewing time measured in hours per week. This is a population mean, mu, not a sample mean, x bar. Mu is 15. Sample size n is 64 because 64 Americans were selected. Population standard deviation is 4, so sigma is 4. For question 1, the population of interest is all Americans in year 2003. Question 2 asks for the population size, capitalized N, that is different from the sample size n, small letter n. Sample size small letter n is 64. Population size is the number of all Americans in 2003. According to Wikipedia, that's about 290 million. Question 3 asks for the total number of different ways of drawing sample 64 from 290 million. You may remember that drawing 30 from 180 is already a very large number with more than 30 zeros behind it. I would not recommend you to use a calculator to figure this one out, as you probably get an error message. You don't have to calculate the exact number. You just need to know this is probably a very large number. There are going to be almost uncountable number of ways of drawing 64 from 290 million. Question 4 asks for the sampling distribution of a sample mean. We will use the central limit theorem CLT to answer this question. Before we do that, we would have to verify whether CLT is applicable here, meaning whether the conditions for the CLT are satisfied. There are two parts to the CLT. The first part of the CLT requires the population to follow a normal distribution. We do not know whether this is true or not, so we fail to use this part of the CLT. The second part of the CLT requires that the sample size to be more than 30. Our sample size is 64, so we should be able to use the second part of the CLT. According to the CLT, sample mean is a normal distribution with a mean same as population mean mu, 15, and a standard error that is sigma over square root n. So that is a 4 over square root 64. That's a half. Therefore, for question 4, the distribution of a sample mean is a normal distribution with a mean 15 and a standard error of a half. The shape of this distribution is a bell curve. The standard error is the standard deviation of the sample mean, whereas population standard deviation measures the spread of the population. Question 5 asks for a probability within 1 hour of the population mean. Population mean mu is 15. Within 1 hour of 15 is between 14 and 16 hours. Notice that 14 and 16 are actual observations. We have to convert them to their respective z-scores so that we can look up the z-tables to find the probability in the middle portion. The z-score formula is observation subtract mean divided by standard deviation. It is very important to know that the mean and the standard deviations here are all the mean and the standard error for the sample mean, not for the population. So they should be 15 and a half, which were found in question 4. After looking up for two z-scores on the z-table, we use the bigger probability subtract the smaller probability. The final answer is 0.9544. Question 6 is fairly similar to question 5. So again, you want to convert 14.25 and 16.5 to their respective z-scores. And the mean and the standard deviation for converting z-score are the mean and the standard deviation for the x bar. Example 2 is about how much students spend on food each day in a college. The variable of interest, how much they spend on food, is a numerical variable. We write down the various variables first before we move on to the individual question. Question 1 asks for the expected value, which is an alternative way of saying the center. According to the CLT, again, we are using the second result of CLT because the sample size is more than 30. Sample mean is normal distribution with center 10.50 and a standard error of a half. The shape of the sampling distribution is a bell curve. Question 2 asks for an upper-tailed probability x bar more than 11.41. We first convert 11.41 to its corresponding z-score, that is to subtract the mean of 10.50 and divide by the standard deviation of a sample mean, that is half, not the population standard deviation of 4. Looking up the z-table for 1.82, and then subtract this probability from 1, we get an upper-tailed probability of 0.0344. Question 3 is fairly similar to previous examples. Example 3 is for the proportion of a business major students. The variable of interest here, whether a student is a business major or not, is a categorical variable. It's no longer numerical variables like examples 1 and 2. We first write down population proportion P as 0.20 and the sample size N is 100. Question 1 asks for the standard error of a proportion. First, we would have to check to see whether the conditions of the CLT are met here. For sample proportion, we need to check sample size times population proportion, that is N multiplied by P is at least 10, and N times 1 minus P is also at least 10. Both conditions are satisfied here. According to the CLT, sample proportions are normally distributed with a mean population proportion that is 20% and a standard deviation of 0.04. Therefore, the standard error is 0.04. Question 2 asks for the sample to have at least 12 business majors. The sample size is 100. Having at least 12 business majors is the same as having a sample proportion greater than or equal to 12 over 100. That's 12%. 12% is our observation. This can be converted to z-score of a -2 using observation subtract the mean divided by standard deviation again. The mean here would be the mean of the sampling distribution of the sample proportion, that is 0.20, and the standard deviation is the standard error of 0.04 that's calculated in question 1. 12% has a z-score of a -2. We would again look up for lower-tailed probability first, and then subtract that from 1 to get an upper-tailed probability. And the final answer is 0.9772. Question 3 is identical to previous question. Instead of having P bar more than 12%, we would have to find a probability for P bar less than 15%. The final probability would be 0.1056. The key to solving probabilities involving sampling distributions of sample statistics is to make sure that we use the standard errors of the sample statistics.